So last lesson, we talked about the compound interest formula and how to calculate future value. So we would get the present value, we'd get the information like the rate and how many times it compounds a year and for how long. We could plug all those things in and find a future value. Now we're going to look at what happens if you get different pieces of information and need to find something else. Like maybe you need to find the present value, or maybe you need to find what the annualized rate was. How do you do that? How do you use the information you have to find the things that you need? So we're just going to go through a couple examples of that, how to put it into Desmos calculator. If you just go to desmos.com for the calculator, how to put it in there. And you get a couple examples for your notes, and you should be good to go, and then practice a little bit.
So we could solve for different things, though. We talked about that on Thursday. In this case, we're going to solve for the present value, the principal, or the initial value. So you'll see some like this. Over here, it says I made a one-time investment 17 years ago. So 17 years. It earned 3.5% compounding monthly. And then the balance is now 32,150. What was the initial investment? So this is compounding monthly. Of course, we're going to use the regular compounding in a finite way formula. So we will list these babies out. So 17 years. It's compounding monthly, so that's 12 times a year. The rate was 3.5% as a decimal is this. Let's see. The present value, we don't really know. The initial value, the principal, we don't know that. But we do know after 17 years that now it's 32,150. So we're actually solving for P this time, and it's going to take a little bit of solving skill. So when we plug these in, we're looking at 32,150 equals P times 1 plus 0.035 over 12 to the NT. So 12 times 17. Okay. This is just like if we had something like 15 equals P times 3. Okay, this is just a number right here. This number, you could plug it into a calculator and it'll give you a number. The problem is it's going to be a crazy number. It's going to be 1.0765789, and you're not going to, you won't be able to write it. So what we're going to do is just treat that as a number itself. So like up here, exactly how you would divide by 3 to make that 1. Divide by 3 to make this 5 and say that P equals 5. Exactly how you would solve a little simple equation like that is how you're going to solve this one. So we're going to just say, since it's P times this, let's just divide by that. And we're going to divide that over here too. 1 plus. So anything divided by itself will be 1. So this thing here, right, is being divided by itself. So that means that is 1. And 1 times P is just P. So we're left with P equals, and then whatever this is, right? We're going to have to toss that into a calculator. So let's look at how to toss that into a calculator. You type in the 32,150, you hit the divide button, the backslash, and then we can open parentheses and say 1 plus, okay, it was 0.035, so that was the rate. We're going to divide that by n, which was 12. Then we hit the over arrow to get out, close the parentheses, shift 6, the caret to get into the exponent. And what was it here? 12 times 17. So 12 times 17, close parentheses, and there you go. 17,748. So what does that mean? That means that this amount was what was initially invested, and after those 17 years, growing at 3.5%, it ended up becoming 32,150. So this was the initial investment amount. Solving for rate. So we're always going to, when we're solving for rate, we are always going to use the finite equation. And we're just going to assume a yearly compounding because that's what we care about when we ask this question. When we say what has been your average annual returns, we're referring specifically to annually. Like, what have you gotten year over year over year? So we're considering those when we ask that question. We're considering yearly. So we're just going to use this, and we're going to say that n is 1. N is 1 there. So let's fill these out again. So an investment of 12.5 30 years ago. I now have a balance of 100,000. What was the average rate of return? Well, we know n is 1 because we just decided that because that's what doesn't specify, and that's what we're really kind of looking at. So we're going to say that future value 100,000 equals the original 12.5 times 1 plus, now r over n, if n is 1, that means it's r over 1. And anything divided by 1 is just itself. So r divided by 1 is r. And I'll just put that as an r so I don't have to write another step. And then same thing for nt. When it says n times t, well, n is 1. So 1 times t is just t. 1 times itself is just t. So we're just talking about 30 right here. Okay. So we don't have to worry about those other guys. We got to solve for r. So this one takes the most amount of like solving skill here, but certainly doable. And I'll show you what's going on here. So we just got to unwrap it one step at a time, and we're going to start away from r and work towards it. And r is stuck inside these parentheses. We have to free it first by getting rid of all these other things. So just like the start of the other ones, since it's 12,500 times this, the inverse of multiplying is dividing. So I can divide that. How's that help us? 12.5 divided by 12.5 is just 1. So that gives us 1 times anything is itself. So we still have that. And then let's see, 100,000 divided by 12.5. Is that going to be a nice number? If it is, we'll switch it. If it's not, we'll just keep it. 8. Okay, it's a perfect number. Okay, so if this was ugly, you could just keep it as this divided by this. That's fine. But it's 8, so that's very nice. And then the next step, I need to get rid of this 30. So the inverse of taking an exponent is taking a root. So we make the little radical symbol on both sides. Well, what root do we need to take to cancel out a 30 exponent? We need to take the 30th root. 30th root. So this 30th root will cancel out the 30th exponent. We will get 1 plus r. No more need for the parentheses since all of the outside stuff is gone now. The 12.5 is gone. The 30 is gone. So we don't need these parentheses. It's just 1 plus r over here. The 30th root of 8 will certainly not be a nice number. So we're just going to leave it. We'll leave it the 30th root of 8. That's fine. And then the last step, 1 plus r. If we're solving for r, we need to get rid of this 1 so we can subtract it. 1 minus 1 is 0, so it goes away. So minus 1. And you'll say that r equals the 30th root of 8 minus 1. Now, obviously, no one can do the 30th root of 8 in their head. So we're going to throw that in a calculator. Okay, let me show you how to put that in a calculator. You have to type nth root. And it'll give you the nth root. You got to type that out. Nth root. It's just saying some n is a placeholder for the number. So some root, in this case, it'll be the 30th root. But that's what you type that out, nth root, and you see it gives you a little spot up here. And that's where I can put 30. Okay. And then 8, hit over to get out of it so that you can subtract 1. Because I'll show you what happens. Nth root, 30, you hit over to get there, and it's 8. Now, if you don't hit over, you'll hit -1 and you see how it stays in there. And this is doing 8 minus 1, which is 7, and it's taking the 30th root of 7. So you don't want that. You want to be outside. You want the 30th root of 8, hit over, and then subtract 1. There you go. 0.0717. Okay? So it says then that R is 0.0717. Now, is that 0.0717%? No, this is a decimal version of a percent. Just like when you convert a percentage to a decimal by moving the decimal to the left twice, you can convert it back by moving it to the right twice. 1, 2. So that is 7.17% here. Your rate, your average annual rate, average annual return rate was a little over 7% over those 30 years, and it turned your 12,000 into 100,000. And they're pretty much all going to be solved that way. So, just kind of follow those steps. It takes a little bit of just keeping track of where the numbers are and what's going on, and making sure it's going into your calculator correctly.